So, welcome to Merritt's Emergency Physics, Chapter 5, Section 2. Now, this is no different from Section 1, but I do want to make sure that the video is still filming. I just heard a weird, strange sound. Are we still filming? Yes, we are still filming. Okay. I'm not going to solve this problem for you, but I'm going to give you some help here. Now, in this case, we've got a simple roller coaster. We're going down, we go up, and we go down again. But there's some key differences from the first problem. First off, the numbers are bigger. Bigger numbers, more stress, right? Don't worry about it. We got calculators. The second thing is, they have not told you the mass of the roller coaster cart, have they? And this thing, it just says a cart. It doesn't tell you it's the same mass or anything like that. It doesn't even say the cart. It's like, hey, roller coaster. So we don't actually know the mass yet. But you know what? For most of the problems, that's not going to be a problem at all. So, you know at point B, 95 meters up, your velocity is 40 meters per second. So that's the point where you have the most information. But what they want you to find is your velocity at point A. What is going to be the velocity when you start it? Let me tell you something about roller coasters. The roller coaster runs the same whether it's an empty train of carts, or if the train is full of full of linebackers. It doesn't matter if you put a fat person in a roller coaster. You put a fat person in a roller coaster, it isn't like one car gets hit by another car coming up behind because it's got a bunch of skinny people in it. As long as the person doesn't break the roller coaster, it goes through exactly the same way. Makes sense, right? Think about it. Heavier objects don't fall faster than lighter objects. It makes sense physically, and it's going to work for you mathematically. And let me show you how. Okay, so start out. What do we know? We know the mechanical energy at B is going to equal, I'm giving myself some space here, the mechanical energy at A. So, mechanical, actually I wrote it down differently in my notes, so I'm just going to change it. Mechanical energy of A is equal to mechanical energy of B. It's going to reduce the confusion. I'm sorry about that. Potential energy plus kinetic energy is your mechanical energy. So mechanical energy is the same everywhere. Potential energy plus the kinetic energy at A is going to equal the potential energy at B plus the kinetic energy at B. Now, okay, we're just going to go down here a little bit more. Okay, so potential energy is mgh at A plus 1/2 mv velocity at A squared is equal to mass times gravity times the height at B plus 1/2 the mass times the velocity at B squared. That's all stuff we've done before, but here's the thing I want to do. Well, I'm going to put some stuff in. Well, actually, I'm not going to put some stuff in here. We know the height, we know gravity, we don't know the mass. That's one big problem, because we're going to try to find the velocity at A, and we know G, we know the height at A, we know everything except for we have two unknowns. We've got the mass is unknown, and the velocity we're trying to find is also unknown. That's two unknowns. We can't do that, but there is something we can do. So you notice mass and mass. So we can do this. Mass, G, H, A. So you see what I've done? I've taken the mass out. It's the distributive, I think it's the distributive property. Using the distributive property to take the mass out of the equation, plus 1/2 V A squared. See how I've done that? And over here I'm going to do the same thing, taking the mass out. Mass, GH B plus 1/2 VB squared. I've taken the mass out on both sides. And then I can eliminate it. Divide both sides by the mass, and I get down here G, that's G, earthlings, HA plus 1/2 VA squared is equal to GHB plus 1/2 VB squared. And that is not solved, is it? But I'll bet you could do it from here. Because, I mean, you earthlings probably know that on Earth gravity is 9.8, the height at A is 140 plus 1/2. Well, this is our one unknown. We don't know what the velocity is there. Don't forget the square root is equal to the whole roller coaster on Earth, isn't it, earthlings? Height there was 95 plus 1/2, and we knew the velocity there was 40 squared. You can solve for VA. Now you've got something you can solve for, and I'll bet you can do it. Now, by the way, what if I get it wrong? Mr. Merrill, what if I get it wrong? Don't worry. Well, do worry. Don't not worry. But what can we tell you? So, it's going 40 meters per second here. Up here it's higher. So where is it going to be faster? Lower? Or is it going to be faster when it started up high? Well, it's faster down here. So whenever you find VA, you can be sure that it's going to be less than 40